Our problem for today is, suppose a crate is pulled to the right as shown, but is also being lifted a little bit as shown. So we got a 30 Newton force pulling up, a 50 Newton force pulling it to the right. It's also sliding across the surface with a constant velocity to the right. Okay, so I want you to draw the free body diagram and then figure out the friction force, the normal force, and then the coefficient of friction. So let's do that. Let me zoom out a little bit. So given, well, I don't need to redraw the picture. Actually, what's given is up here. So let's just do the find. We want the free body diagram. We want the force of friction. We want the normal force. And then we want mu. Okay, so let's solve. Now the free body diagram, so here's our object, and here's our crate, and obviously it's being pulled with 50 newtons to the right. It's being lifted with 30 newtons. These are two applied forces. Now gravity's pulling it down, and then we have the force of friction like this. Now, just to stay with the procedure, we'll define this to be the x direction and this to be the y direction. And now we'll do, so this is part A. Now, let's do part B. I do part B by starting off by summing, look, the force of friction is one of the x direction forces, so we'll sum the forces in the x direction equals ma in the x direction. So I'll look in the x direction. I've only got two forces, 50 newtons minus the force of friction equals, now it says that this object is moving with constant velocity, so the acceleration is 0, so that's equal to 0. So therefore, this is quite easy. The force of friction is 50 newtons. Okay, did you get that? Everybody happy with that? Okay. Simple enough. Okay, now part C is a little bit more complicated, though. You have to really look at the free body diagram carefully. Oh, I left the force off my free body diagram. I apologize. I left what we're trying to find. Okay, we got this normal force, and so if I sum the forces in the y direction, that's going to be equal to ma in the y direction. And but see, now I got 1, 2, 3 forces now in the y direction, so I have to include them all. And so in the upward force is a normal force plus 30 newtons. And then mg, well, what is mg? Well, it's 20 kilograms times 9.8 newtons per kilogram, which is 196 newtons. Okay, so I'll just include that. But it's down, so it's, this is down, we'll subtract it, equals, so here I've summed all the forces in the y direction, see, and then equals ma. Well, what is a in the y direction? What is the acceleration in the y direction? 0. And so now I can solve for the normal force. It's, it's 196 newtons minus 30 newtons, right, if I put both of these on the other side. So the normal force is equal to 166 newtons. Is that what you got? Okay. Good. And then, so now D is pretty easy. It's 50 newtons divided by 166 newtons. So mu is equal, what is 50 divided by 166? Don't make me find my calculator, God. What is it? 0.301. That seems reasonable to me. About a third. Wait, it should be more. Is it 0.301? Is it? Okay. Okay. Now, here's the big idea and why I gave this. This is a good review of the last unit, but also we need to now be very careful about summing the forces in the y direction, because some of the stuff that we're going to be doing, the normal force has always been equal to the weight. I mean, that's when we've had a crate problem. It's like the normal force is always equal to the weight. Now we're going to complicate things. And there could be another force in the y direction, and you'll have to account for that. But if you follow the procedure carefully, if you draw the free body diagram, identify the x and y direction, and you know, use Newton's second law, you'll be able to do it. Okay? And any questions on this lovely little problem here? Okay. That is all then.